Good afternoon. My name is JS. I'm the one in charge of physics tutorial and jasoncharitys support foundation. Today we want to continue with the topic at hand. We are dealing with motion. And last week we tried to look into what motion is, and some examples and types of motion. So we said the motion involves a change of position of a body with time. So a change of position of body with time. That is what we refer to as motion. Now we have talked about different forms of motion. We talk about the random motion. We talk about the translational motion. We talk about the rotational motion, oscillatory motion, and we talk about the relative motion. We've talked about the types of motion. We talk about the examples that are there. Today now we want to move forward on that motion, so whereby we'll be talking about the speed and velocity. So whereby we're talking about the speed and velocity. So let's first start with the speed under the motion. Remember that in describing the motion of a body, so we note both the distance and time it takes to cover that distance. So in describing the motion of a body, the best thing to note is the distance and time it takes to cover the distance. The body, the distance and time it takes to cover the distance. The body, the time and distance that it takes the body to cover the distance. When we are dealing with motion, those things are very, very essential. So while dealing with motion, so we must talk about the distance, time it takes to cover the distance, so by a body. Now, the rate at which a body covers a distance is called the speed of the body. The rate by which a body covers a distance is the speed of a body. Sometimes a body may take 500 kilometers, some may take 500 meters. The rate, so all the rate at which a body covers a distance, so it's what we refer to as the speed of the body. Now, thus, if you want to calculate the speed now, this will be calculated by speed will be equal to distance all over time. To get the speed a body travels, we have to get the distance. So of the distance the body travels and the time it takes for the body to travel the distance. And once we get that, then we can get the speed by which the body travels. The rate of the distance covered by the body and the time it takes to cover the distance, that is what the speed of a body can be calculated in. So that is an average speed over the distance. So thus, now sometimes the average speed, average is bar velocity is equal to distance all over time. This is all of S all over T. Now, the speed is measured, we get the speed by the rate of the distance traveled by a body all over the time taken. So the average speed, to find the average speed is equal to distance all over time. And remember that distance is measured in meters. Distance is measured in meters. So that is the derived unit or the fundamental unit of distance, sorry, is meter. While the fundamental unit of time is second. When you calculate the speed, then the SI unit of the speed will be meter per second. So I'm just branching there to remind you what we have done so far. Now, other multiple of that unit are centimeter per second and kilometer per second. Centimeter per second, sometimes it may be centimeter per second or kilometer per second. So it depends on how the question comes. When it's come in meter, we solve it in meter. When it comes in centimeter, we solve it in centimeter. So you cannot solve meter and let me say hour together. You can solve meter and second. So you can solve kilometer and hour, so together. But as we move on, we talk about that. Let me just, for instance, so let me give you an example to buttress my point. If a bus cover a distance of 200 kilometers in 2 hours, if a bus cover 200 kilometer hours. So find the speed. Find the speed. Speed of the what? Of the bus. Now, if you look at the parameter given in the question now, so we were given kilometer and we were given hours. We are talking about speed before. It has to be measured in the distance all over time. And yes, the distance is given here and the time is given. So how the question is given is determined, but you have to be very, very sensitive about the question. If you were asked to leave your answer in meter per second, then you leave it in meter per second. Then, like this one now, your answer will be in kilometer per hour because your distance were given in kilometer and your time is given hour. Cover 200 kilometers in 2 hours. Find the speed of the bus. So distance all over time will be equal to, our distance here now is 200 kilometers. 200 kilometers all over the hour time. 2. Now, 2 in 20, that will give you 10. 2 in 20, 10 and 0. Then the speed covered, the speed traveled by the bus is 100 kilometers per hour. So 100 kilometers per hour. The car travel at 100 kilometers per hour. Meaning that when it covers 100 kilometers per hour, it must definitely cover 200 kilometers in 2 hours. Now, what we just find now is average speed. This is average speed. Now, let's talk about the uniform speed now. The uniform speed. When you were asked to find the average speed, that is distance all over time. Let's talk about where we are dealing with the speed and velocity. We are under the speed now, uniform speed. So uniform speed. So when we talk about uniform speed, what are we talking about? When the body covers equal distances in equal time intervals, when they cover equal distances in equal time interval. So no matter how small the time interval may be, the speed is said to be a uniform speed or constant speed. No matter how small it may be, the speed is said to be a uniform speed or constant speed. So let me come again so you can understand. When the body covers equal distances in equal time interval, no matter how small the time interval may be, the speed is said to be an uniform speed. So when you cover equal distances in equal time, equal distances in equal time, equal distance in equal time. So it is said to be on a uniform speed or constant speed. That is what uniform speed is all about. Now, that is what you need to understand about the uniform speed. Let us quickly talk about the velocity. We talk about velocity, then we can quickly move into the calculations. We can quickly move to the calculations. So, we can quickly move into the calculations. Now, velocity. So, velocity is defined in terms of displacement. That is, velocity is the rate of change of displacement. We talk about velocity, so it's the rate of change of displacement. It deals with displacement, the rate of change so of displacement. That is what we refer to as velocity. And what we are talking about, the rate of change of displacement is referred to as velocity, whereby velocity is equal to displacement all over time. So that is the formula for calculating velocity, rate of displacement, the change of rate of displacement, that is referred to as velocity. And this is equal to B is equal to S all over T. That is velocity. Let's quickly move on. We can get something tangible done. So let's talk about the uniform velocity. The rate of change now let's move into the uniform velocity. Uniform velocity. We talked about speed before, we talked about the uniform speed. So let's talk about the uniform velocity now. The uniform velocity. So let's talk about the uniform velocity now. What is uniform velocity? When the body moves with equal displacement in equal time interval. When the body moves in equal displacement with equal time interval. So the body is said to be in a uniform or constant velocity. When the body moves with equal displacement in equal time interval. So no matter how small the time might be, so the velocity is said to be in uniform or constant velocity. And do not forget that the unit of velocity is meter per second. So you should understand the velocity, the uniform velocity, and uniform speed. So uniform speed, as I said before, so when the body covers equal distances in equal time. Now, velocity is when the body moves with equal displacement in equal time interval. So that is the differences between the uniform speed and the uniform velocity. So if the body moves around the circular path at constant speed, then it's said to move with non-uniform velocity. So when the body moves around the circular path at a constant speed, of motion is constantly changing. The reason is because the direction of motion is constantly changing. When the body is moving around in a circular pattern, the direction of it will be changing. You cannot compare with a body that is moving on a straight line. Now, the body will maintain, is it possible for the body to maintain a uniform velocity or a constant speed? So, but the body that is moving in circular, motion, so it's said to be a no uniform velocity, because the direction of motion is constantly changing. Now, so let's look into some little calculation. A car travels at an average speed of 100 kilometers per hour. A car travels at an average speed of 100 kilometers per hour. Of 100 kilometers per hour. What distance does it cover in 5 minutes? What distance does it cover? Cover in 5 minutes? What distance does it cover in 5 minutes? Yeah, that is the question. Start with this. So when you are dealing with calculation in physics, it's not that maybe physics calculation is as tough as we used to think. The only problem we used to have while dealing with calculation in physics is that we don't use to understand the concept of the question. When we understand what the question is talking about, then it will be very easy for us to get the correct solution of the answer. So let's look at the question now. Let's look at the solution. Now, it's a car travels at an average speed of 100 kilometers per hour. An average speed of 100 kilometers per hour. No, there is a confusion here that you just need to understand first. A car travels at an average speed of 100 kilometers per hour. So, average of 100 kilometers per hour. This will be something like 100 kilometers per hour will be equal to 100 all over 60. What am I doing here? 100 over 60, that is kilometer per minute. I'm trying to combine the kilometer per minute. It was a kilometer per hour here. So 100 kilometers per hour. So 100 all over 60, that is the kilometer per minute. Now, what they ask us to find, what distance does it cover in 5 minutes? What distance does it cover in 5 minutes? Now, what I do here is the kilometer, the average kilometer that the car travels per minute. So They said, what distance does it cover in 5 minutes? We need to convert this to minutes because we were asked to find the distance that it covers in 5 minutes. If we were asked to find the distance it covers in maybe 5 hours or in 2 hours, there's no need to convert this into kilometer per minute. But because we were asked to find what distance does it cover in 5 minutes, so with that reason, we have to convert it into minutes. So don't forget, we were asked to what distance? What distance? Before we can find distance, do not forget that speed is equal to distance all over time. That's how we do it. From the question now, when we can arrange it, when we cross multiply this, we were given speed and we're given time, but we were asked to find distance. So let us cross multiply. This will be equal to, this will be distance, it will be equal to speed times time. I don't want to rush, so you get to understand what I'm trying to explain here. Speed is equal to distance all over time. The question says, what is the distance what distance does it cover in 5 minutes? We were asked distance. We were asked to find the distance. And to find the distance, we must use the formula for the speed. And the formula for the speed is equal to distance all over time. So we can get to know our speed and we have our time. But the distance is what we need to find. So we can cross multiply. Then distance is equal to speed times time. So with our speed now, we multiply the speed by time, then we get our final answer. So what is the speed? The speed, a car travel at an average speed of 100 kilometers per hour. This is in an hour, 100 kilometers per hour. So they say what distance does it cover in 5 minutes? So our speed now is 100 all over 60. This is equal to 100 all over 60. It's not showing. Okay. Let me try to rub this upper part. I don't want to rub the question. Yeah. The question is still visible on the chalkboard. A car travels at an average speed of 100 kilometers per hour. It travels at an average speed of 100 kilometers per hour. What distance does it cover in 5 minutes? That is the question. Now, what distance does it cover in 5 minutes? We have to know the distance it covers in 5 minutes, but it was given hour. So we have to deal with this distance it covers in minutes and to know the distance that the car travel in each minute. We need to divide this 100 kilometers by 60. By dividing the 100 kilometers by 60, we are going to get the distance that the car travel in a minute. I don't want you to get twisted. So by dividing this 100 by 60, that means we get the distance the car travel in a minute, because what they want us to do is the distance the car cover in 5 minutes. You have to understand that. So when we get to know the distance the car travel in a minute, then to get the distance travel in 5 minutes will be very easy. So the formula for speed is equal to distance over time, but we are trying to find the distance. We were given the speed. So no distance. We can cross multiply distance because of speed times time. That's what we are. That is what we are trying to do here. Now, this will be equal to 100. Distance is what speed over time. Our speed now is 100 divided by 60. Speed is equal to 100 divided by 60. That is speed times time. What is our time? 5 minutes. So I hope you are getting me right. If we multiply 100 by 5, we will get 500. So this will be equal to 500 all over 60. Divided by 6, this is equal to like 8.3 kilometer. Okay, let me explain again. A car travels at an average speed of 100 kilometers per hour. What distance does it cover in 5 minutes? The average speed of the car is 100 kilometers per hour. That is, the car travels at 100 kilometers in an hour. They are asking us that what distance does it cover in just 5 minutes? What is here is an hour. 100 kilometers is what the car travels in an hour. And to get the speed the car travels in a minute now, we have to divide the 100 by 60. And that's what we do here. 100 kilometers is what 100 divided by 60. So by dividing 100 by 60, we get to know this time the car travel in a minute. It's about distance over time. This is the best formula we can use for the calculation. Speed of distance over time. Speed is given in the calculation, which is 100 kilometers per hour. So distance is not given. Time is given, 5 minutes. Now we can now say that we know speed is equal to, we cross multiply this formula so that it can be very easy for us. If you don't want to do that, you can just fit it directly by saying 100 all over 60 is equal to distance all over 5. 100 all over 60 is equal to distance all over 5. Let me illustrate this here. Then you get to know it won't be like I just do cross multiplication without you understanding. Remember that this speed is equal to distance all over time. So what is our speed? Our speed is equal to 100 all over 60 times distance. Our distance is not given. Distance is not given. Distance is not given. All over time. What is our time? Given 5 minutes. 5. Sorry. Equal to, this is not times, because speed is equal to distance all over time. So with this now, 1 over 60 is equal to distance all over 5. Then we can do a cross multiplication. When we do this one, 100 divided by 60, whatever we get here, we are going to use it to cross multiply this. Then this will multiply 5 and distance will come out. And that was how we got speed. Distance is equal to speed times time. As simple as that. So you just have it at the back of your mind that speed is equal to distance all over time. So by cross multiply, we were given speed, we were given time, we were not given distance. We can cross multiply directly. Distance is equal to speed times time. And that was how we arrived at this. So speed is equal to distance. Sorry, there's a mistake here. Distance is equal to speed times time. And now the speed the car travel is 100 all over 60 times time, which is what? 5 minutes. They are asking that how many minutes, what distance does the car cover in 5 minutes? So this is the time given to us, which is 5 minutes. So 100 over 60 times 5 minutes, this will give us 8.3 kilometers. So why was our answer unit is in kilometer? It is because we asked that what distance does it cover in 5 minutes? Now the distance here is in kilometer. Do not forget that when we were dealing with the fundamental and derived unit, so we said that distance is measured in meter. So it's measured in meter. But the reason why this one is in kilometer is because the speed is given in kilometer per hour. And the answer must also be in kilometer. I believe that the speed is given in meter. Then the distance will also be in meter. But the speed is given in 100 kilometers per hour. So the distance will also be in kilometer. So finding the meter, the SI unit of the fundamental unit of meter is distance is meter. Now, but it is kilometer. That is why the speed is in kilometer per hour. That is why the distance is in 8.3 kilometer. Simple as that. So I hope you understand that. I hope you understand that. So let's try to look into another question.
Can you hear me?
A car travels.
Can you hear me?
At a speed of 1,000 meters.
Joshua, can you hear me?
1,000 meters per 1,000 meters per 1,000 meters per second. A car travels at the speed of 1,000 meters per second. What distance does it cover? Does it cover in 25 seconds? This question is just like the other question, but another version of it. So with this one now, you will get the clear understanding of the previous question that we solved. A car travels at a speed of 100 meters per second. What distance does it cover in 25 seconds? Solution. Speed is equal to distance all over time. The distance is given directly. Everything is in second, meter second, 20 seconds. So our speed is 1,000 meters per second is equal to, distance is not given. Distance is not given. All over time. What our time is 25 seconds. 25 seconds. Now this is a parameter. Now this will be like something all over 1,000 meters per second over 1. So we can now do cross multiplication. When you do cross multiplication, distance will be equal to 1,000 meters per second times 25 seconds. 1,000 meters per second times 25 seconds. So when we multiply 1,000 times 25, this will be equal to, distance will be equal to 25,000 meters. If the car travels at a speed of 100 meters per second, what distance does it cover in 25 seconds? Now, the speed is equal to distance over time. We were given speed, we were not given distance, we were given time. Now, a car travels at a speed, the speed is 1,000 meters per second. This is the 1,000 meters per second. So it's equal to distance. Distance is not given. The time is 25 seconds. Now we cross multiply. Distance is equal to 1,000 meters per second times 25 seconds. So this will give us 25,000 seconds. It travels 25,000 meters in 25 seconds. So with that, I hope you understand the concept.
Can you hear me, sir?
Now, what we're moving into now, if the time permits us, we will talk a little about is acceleration. Acceleration. So if the time didn't permit us, we explain better about it in our next class. Acceleration, we've talked about acceleration under the fundamental and derived quantity. And we say acceleration is defined as the rate of change of velocity with time. The rate of change of velocity with time. The rate of change of velocity with time. That is what we refer to as what? Acceleration. So it deals with the rate of change of velocity with time. So it is measured in meter per second square. It is measured in meter per second square.